Hey pre-algebra, we are on to our second section of the first chapter. We're looking at variables and expressions. As you can see, here's our list of vocabulary words for this section. The word algebra, variable, algebraic expression, defining a variable, substitution property of equalities are the vocabulary words that we're going to use in this section. Algebra, for our intents and purposes, is merely a branch of mathematics that uses symbols, and we'll be using variables, and we'll talk about that in a moment. So the symbols often used in algebra are called variables, and they can change. It's usually a letter or a symbol used to represent an unknown value. For instance, I can say x plus 3 and is equal to, let's say, 5. You would know in this case automatically that in this case x is equal to 2. However, if we had something like 2x plus 5 equals 7, we see that 2 doesn't work here. For 2 times 2 plus 5 equals 7 is an untrue statement. So what that tells me in this case is that x can be different things, and hence the word variables. So we use the word variable meaning that it can vary, it can change. And in this case, if you were to look closely, you'd see that x was equal to 1 because 2 times 1 plus 5 is indeed equal to 7. We've come to algebraic expression. From our last lesson, we talked about just a numerical expression being a collection of numbers and signs. With an algebraic expression, generally we have a variable involved. So we could have x plus 5. That is an algebraic expression. 5 minus y, algebraic expression. So this final vocabulary term is not really a vocabulary word, it's a phrase or a property, and we'll be talking about properties in the next section. But there's something called the substitution property of equality, and that reads, this word if shouldn't be here, but for two numbers a and b, if a is equal to b, then a may be replaced by b. Properties in algebra sometimes seem basic and really obvious, but what they do is they give us permission to use techniques to solve problems. So even though this seems really basic, we're going to actually use this property a little bit later. It'll give us permission to evaluate some algebraic expressions. Another concept that I meant to introduce earlier, but I think this is a fine time, is the idea of defining a variable. When you define a variable, it's really probably the most key important step in translating a verbal phrase into algebraic expressions. So that's something that you want to do kind of right off the bat. After you make sure you understand a problem, you want to make sure and define a variable. It can be crucial to you actually solving the problem. And finally, here's a quick screen recap of the vocabulary terms that we'll be using in this section. Please pause here if you still need to copy them down. This is the first of a few examples that we'll be doing. Many of the examples have many parts to them, like this has 3 parts. Please be sure to leave yourself some space when copying this down. So this first example is having us translate phrases into algebraic expressions. So let's take a look at the first one. $10 more than the cost of a cup of coffee. The word more lets us know that we're dealing with addition. We realize that the cost of a cup of coffee is our unknown. So this is where our variable will come in. So the first thing we really want to do is define our variable. This is a proper way to define your variable. List the variable you're going to use, C, and tell us what it is. C is the cost of a cup of coffee. Some students get a little lazy and they'll do things like this. C is coffee. Not exactly what we're talking about. Since we're dealing with dollars in this problem, we really need to make sure that C represents the same thing that we're dealing with. And since here we're talking about 10 more, our algebraic expression for this one will be C plus 10. In this example, we're presented with the idea that Lisa has $11 and made $7 an hour babysitting. Now the unknown, as you might see, is the hours babysitting. We have no idea how long she babysat. So what we're going to do is use that. First, we'll define that variable. So H is the number of hours Lisa babysits. So now let's see if we can put all this together. We know that she's already had $11. She gets $7 an hour for babysitting. How can we write an expression that represents how much Lisa has? Simply put, she's got 11 plus she's making some other money. What other money? The money babysitting. Therefore, we do 7 times H, or 11 plus 7H. The final part of example 1 reads 2 miles less than the car traveled. Again, the first thing we should do is figure out what we don't know. And what we don't know is how far that car traveled. So let's define our variable to reflect that. So for us, D is the distance the car traveled. Realize distance is something that's quantifiable. I can write it as a number. You don't just want to put C is the car or D is car or anything like that. We want to make sure we emphasize the numerical value here. So if D is the distance the car traveled, then we know that we're referring to 2 miles less than that. We would do D minus 2. Here's a quick tip for you. A lot of students do this. 2 less than means minus, and I guess D, whatever that is. Some people do that, 2 minus D. You need to really make sure and read the problem before you actually, and make sure you understand what's being asked before you actually try to write it an expression. Let's check out example 2. So here's example 2. Remember to evaluate from our last lesson refers to the fact that we're looking for a numerical value. So we're going to evaluate this algebraic expression given the fact that we're given some information about the variables in it. Recall that we talked about not just defining variables, which we did in the last section, but the substitution property of equality. Here's where we're going to put it to good use. Since we know that y is equal to 12, I can rewrite this expression. Instead of putting y, I'm going to put 12 in there. And instead of putting z in, I'm going to change my z to the number 9. When I do that, I'm left with something that's really easy to evaluate. Noticing that my expression only has addition and subtraction, I'm just going to go left to right using my order of operations. 12 plus 9, that's 21, minus 4 is going to leave us with 17. This next example, example 3, gives us more opportunity in practice in evaluating expressions, especially when we're given some values for the variables. So it's 3 sections. Let's make sure we have enough space in our notes to get all of this information down. So when I see something like this, I immediately want to replace the unknown variables for the known information. Since I know that r is equal to 4, s is equal to 6, and t is equal to 2, I go to this first expression and I replace it. So this, instead of being 3 times s, I've got 3 times 6, and instead of 7 times t, I've got 7 times 2. Again, using order of operations, I'm going to deal with multiplication first, then go from left to right. When I deal with multiplication, I get 18 plus 14, and when I finish it off by just adding them together, 18 plus 14 gives us 32. And that's the answer for part A. If we look over here at part B, the way I would have liked the typing to have looked is more like that. So really r times s over 12. And again, we're going to immediately replace the variables with the known values, and then we'll proceed to solve the problem. So I've got 4 times 6 over 12. Recognizing that this fraction bar is somewhat of a grouping symbol, I need to do what's at the top separately from what's at the bottom. I need to deal with the numerator before I deal with the denominator. So my numerator is 24, my denominator is 12, and I think everybody knows that this will simplify to the number 2. So my answer for part B is 2. All right, just like we've been doing, we're going to replace the values in our algebraic expression with the substituted numerical values that we know the letters have, and then we're just going to proceed. So we see that we have a situation where we've got parentheses. These parentheses, when I have this number outside, remember that means multiplication. So I'm going to rewrite this as 2 plus the quantity of 25 minus 18. Got a little stuck at the bottom, so now we'll just continue the problem this way. So the next thing I need to deal with is what is in the parentheses. 25 minus 18 leaves us with 7. So I end up with 2 plus 7 is equal to, and I think we all know that the answer is 9. So the answer to the last part is 9. So we've reached our final example for this section, and this is always, generally we like to have a little word problem to finish off, but this word problem looks a lot like a problem that we worked on before, Lisa and the babysitting situation. Let's see if you guys can see the relationship. We have a company rents a houseboat for $200 plus an extra $30 per day. We're going to write an expression that can be used to find the total cost to rent a houseboat. And then the second part gives us the specific information. A family, the Gregorian family, decides to rent the houseboat for 6 days. We need to figure out what the total cost will be. So let's take each part separately. Looking at part A, we need to again define our variable. What's our variable? What don't we know? In this case, we don't know how many days this boat will be rented. So here's our expression. Well, before we get to our expression, let's talk about defining our variable. D is the number of days the boat is rented. Now we can get to our expression. If it's $200 flat fee and then a cost for each day, that would end up costing us $30 per day. I'm going to get rid of the number signs and just write it as the dollar signs and just write it as 200 plus 30D. So now that we've gotten that information from the first section, we're going to use that to answer the second part. So part B, suppose this family, the Gregorian family, wants to rent a houseboat for 6 days. What will be the total cost? Well, we have our handy dandy formula here. Simply put, we know that D in this case is equal to 6. And look, we just have one of those problems that we worked on before, an evaluation problem. We'll take 200, add to that 30 times 6. And we get 200 plus 180. And when we add those together, because remember we have to do the multiplication first, when we add those together, we get 380. So it'll cost this family $380 to rent the boat for 6 days. All right, on to the assignment. The assignment that you're required to do after looking at this video will be the following: pages 14 through 15, problems 12 through 17, that's all, 26 through 29, all, and then these separate ones, 31, 36, 37, 38, and 42. Shouldn't take too long, but we'll work on it in class together. And always make sure that you have your notes together in Cornell form, and I'll see you later.